Hi everyone, thanks for tuning into our development track session on managing the complexities of microservices with AWS Proton. My name is Manoj. I'm a technical account manager here at Amazon Web Services. In this session, I'm going to start with talking about the complexities and challenges in managing your ever-growing microservices, and then introduce our new service, AWS Proton, how it can address these challenges. Finally, walk you through a short demo on what the operators, such as platform team or DevOps team's experience, and the development team's experience will look like with AWS Proton. Let us start with asking the question, why microservices have become so popular? Microservices are an architectural and organizational approach to software development where software is composed of small independent services that communicate over well-defined APIs. There are several value propositions for organizations to use microservices, such as it allows small independent teams to take ownership of their services to work more independently and more quickly. This helps to reduce development cycle time. Microservices also allows each services to be independently scaled to meet demand for application feature it supports. Service independence also means an application's resilience to failure. In a monolithic architecture, if a single component fails, it can cause the entire application to fail. With microservices, applications handle total service failure by degrading functionality and not crashing their entire application. Microservices architecture also provides technological freedom to your developers to choose the best tool to solve their specific problems, and also enables them to adopt newer technologies such as container and serverless to build their microservices. Though there are numerous benefits to using microservices, it does come with a set of challenges, especially around operation. In my previous life as a DevOps and cloud operations engineer, when my organization started to adopt microservices architecture, we started to see the numerous benefits I talked about. However, it did come with operational challenges as my organization grew and the number of microservices my team had to manage grew. Since it is important to realize, to operate a single service, a lot of components come together and each of these components has a lot of complexity underneath. For example, setting up a simple web front-end service can require, amongst other things, a compute capability like that provided by ECS Fargate or Lambda, a DNS routing via service like Route 53, load balancing and autoscaling to dynamically respond to the traffic changes, a CI/CD pipeline to ship code quickly to customers. Finally, adding an observability to your service is key in order to monitor for performance degradation and operational analysis. For this, you will use service like CloudWatch. Now with microservices architecture, there are not just one, but a lot of these independent services. Now imagine having to manage hundreds or even thousands of microservices. In the organizations I worked in the past, when I had to deploy a microservice, I worked with my development team to define and create the infrastructure configurations and tie everything together for deployment. And every time the developers wanted to make changes or a new development team wanted to deploy a new service, I had to repeat this cycle so that I can maintain consistency and control among all of these services. When the number of products me and my team supported grew, now we had hundreds of services deployed across different products owned by multiple development teams. Since my team was few engineers supporting hundreds of developers, soon things started to slip through the cracks. We started to see different product teams were configuring services differently, some were not following infrastructure or security best practices. And it becomes very challenging and time-consuming to work with different development teams to push these best practices across already deployed services. I've also seen similar challenges with a lot of customers I interact with. Addressing this operational complexity of growing microservices without the right tool is an uphill battle for even the most capable platform team. To solve this problem, a great approach some of our large customers have taken is to build a shared service platform or an internal developer platform. Through this, their platform team can define standards on security, software delivery, monitoring, and networking to have more control over their infrastructure. And developers are provided with customized self-service interface, streamlined for deploying code, so they can be more productive. These platforms are great since they take away their operational pain point by helping them to deploy consistent stack across their organization, providing better security guardrails, and also helps to manage and update hundreds or thousands of deployed microservices. However, creating these developer platforms is hard. Large enterprises and big tech companies have dedicated teams to do this, but this isn't feasible for most companies, or they don't want to maintain such platforms. So we saw an opportunity to make our customers' life easier, which is why we built AWS Proton. It is our fully managed deployment service for container and serverless applications. We want to make it easy for infrastructure operators and developers to collaborate together, and also to help central infrastructure teams to define architecture templates that has all their best practices, operational tooling, and security policies, and make these templates available to their developers who can add their business logic via containers and Lambda functions. Some of the key features of Proton are: now developers can use Proton to provision their infrastructure code deployment tooling and observability tooling for their projects in a single location. All they have to do is choose a template and provide the required parameters to have their service deployed. And also from the Proton dashboard, infrastructure and development teams can see deployed applications along with their health and pipeline status. Proton creates a new version of application stacks when there's a template change, providing the ability for the customers to see latest recommended version against the currently deployed version. This helps to know which stacks needs to be updated to comply with standards without having to chase different teams. Proton also lets the platform or the development team to update deployed application to the latest recommended version of the template with just one click. Finally, in addition to integration with AWS services such as CloudFormation, CodePipeline, CloudWatch, Proton will also integrate with third-party tools such as Terraform for infrastructure as code, GitHub Actions for CI/CD, Datadog, and New Relic for observability as part of its future roadmap. Before we look at the demo, let's get familiar with some of the key concepts on Proton. Let's start with environments. For Proton, an environment represents the set of shared resources and policies that Proton services are deployed into. These resources can be VPCs, clusters, and shared load balancers or API gateways. You can create several environments such as dev, staging, and prod environments using the same environment template. As an administrator, you need to deploy environments with Proton before a service can be deployed. Now let's look at services. It represents a workload running on an environment. Example, an AWS Fargate web service, an AWS Lambda data processor, and so on. Developers would be able to create a service from a selected service template made available to them by the platform team and deploy it to a compatible environment created by their platform team. Finally, let's look at templates. They help define the services and the environment in which the service will be deployed to. It ties together the infrastructure as code, CI/CD, and observability tools. These templates help the platform teams to enforce best practices and set guardrails. Templates are the heart of Proton. Now let's take a look at what AWS Proton templates are made of. These templates are directories of files that are bundled and placed in your Amazon S3 bucket. These are then referenced to create your environment and service templates. This template directory contains a schema file which uses the Open API format and includes some of the metadata that Proton requires. This also contains information such as parameter names, their description, type whether the parameter is required, its default values, and other options if applicable. And then during the deployment, Proton validates and verifies inputs based on this schema file. Within the template folder, we also have a CloudFormation template, which defines the shared infrastructure for your environment and resources that are used for the service. This folder also contains a pipeline CloudFormation template, which defines the CI/CD pipeline that's used for the service. Both the infrastructure and pipeline templates are using standard CloudFormation methods, and they use Jinja templating engine to indicate the input and output parameters as defined in the schema. Finally, the template folder contains a manifest file that includes the list of templates that will be used to define provisioning of the service infrastructure and the service pipeline. We wanted to make it easy for you to create great Proton templates, and so we have published a growing library of open source templates to quickly get started. These templates are built using well-architected best practices and can be used to deploy production-grade infrastructure. And these are open source, so you can choose to customize these templates to your needs. As of now, we have published templates with common container and serverless use cases, and we will expand this library over time based on your feedback. Now let's look at a demo on how the infrastructure, operator, and developer experience will look like in AWS Proton. In this scenario, as a platform team member, I want to publish a standard template with all the best practices required to deploy a Fargate service with an application load balancer, so that my developers can easily choose and deploy their service using this template, and not having to worry about how all the infrastructure pieces tie together and comply with the organization's standards. Also, I will show how a platform team can easily provide updates, such as adding a container scanning step as part of their CI/CD pipeline to improve security across all the services deployed via a specific Proton template, and giving their developers the ability to update their service to the newly recommended version with one click via Proton. To do this via AWS Proton, as a first step, I will put on my platform team hat. Then I will define and register the environment templates. This is where I can define all the shared resources, such as VPC, cluster, and so on, that will be required by my developer's service. In my case, I'm going to publish an environment template that can be used to deploy an environment with public VPC. Before we publish an environment template, let's quickly look at the environment template files. For this demo, I've downloaded a sample template to deploy Fargate service with an application load balancer. This template is available to download from an AWS Proton sample template library. When we look inside the environment folder, you can see the infrastructure and the schema folder. Within the infrastructure folder, we have a manifest.yaml, which is using a Jinja templating engine and points to a CloudFormation template as highlighted. The other file is the CloudFormation.yaml file with the standard CloudFormation definition with Jinja variable substitution as highlighted. These variables are defined on the schema.yaml file in an open API format. Now let's bundle the entire environment folder and upload to my S3 bucket I've created earlier to store my Proton templates. Now on the console, switch to the AWS Proton service, select the environment template, from there, click on to create environment template. Provide a name, display name, and description to your environment template. Then choose the S3 bucket where the template bundle is stored and created. Now you can see the template has been created, but it's not published. Now select the version 1.0 and publish it. Now my environment template is successfully published and is available for use. Next, using the environment template, the platform team member can then create the environments with single stage or multiple stage, such as staging, production, and so on, for the developers to deploy their services. In my case, I'm just creating a single stage environment. To do this, select the environments, create environment, select the environment template published, give it a name and description, choose an IAM role that will be used by Proton to create the AWS resources. In my case, I'm using the default service role, or you can create a custom role to give least privilege. Next step, you can modify the inputs, but I'm leaving this as default, which are defined in my schema.yaml on the environment template. Click Create. Now my environment is being created. Since we are using CloudFormation in our template, I can see a new stack is being created under CloudFormation. Now let's fast forward to until the stack is created. Now if you go back to Proton, you can see the environment has been successfully created using my template. As a next step, the platform team will publish the service template, which defines the service-related infrastructure, CI/CD, and monitoring. In my case, I want to publish a service template for my developers to quickly deploy a load-balanced ECS Fargate service. Before we publish, let's quickly look at the service template files. These are very similar to environment templates. The only key difference is I also define a pipeline CloudFormation for the CI/CD. Now let's bundle this template file and upload to our S3 bucket. On the console, create service templates with the necessary details. Choose the S3 location with the template bundle. Define the compatible environment on which the service can be deployed. And then create the service template. Now the template is created, but it's not published. Let's publish version 1.0 of this template for our developers to use. To deploy a service, now the developers just have to choose the service template published to them and link their source code repository. Provide the necessary input parameters and choose the environment to deploy their service. Now let's see the developer experience in action. Now I put on my developer hat, and if me and my development team need to deploy a Fargate service with an application load balancer, I can simply go onto my familiar AWS console. Select the service under AWS Proton and click Create Service. Select the template made available to me by my platform team. Provide the service information. And then I'll provide my code repository ID and branch, then select the connection ID to my GitHub repository already created via AWS CodeStar. Now I create an instance to select the environment stages I want my services to be deployed to. In my case, I only have one production environment deployed, so I'll select that, leaving everything else default. Click Create. Now the service is being created. Let's fast forward to the completion. Now under CloudFormation, I can see there are two CloudFormation stacks deployed, one for the infrastructure and the other for the pipeline. Under Code Pipeline, I can see my pipeline was created and ran successfully. Going back to my service, you can see our service instance is created in our prod environment. We can go into our service instance. Under the output, we can see our service endpoint. And I'm able to access my service via this endpoint. Now it was easy for me as a developer to deploy my service using the published template. All I had to do was specify my code repository, and I have my service deployed quickly, and also I'm adhering to the infrastructure best practices and the guardrails specified by my platform team. We looked at deploying a service, but that is half the battle. The other challenge for platform team is to manage the lifecycle of these services. With microservices architecture, there are a number of independent services, and it is hard to keep track of infrastructure changes across all these services and keeping it consistent. With Proton, since the environment and the service templates are managed as versions, you can quickly see which services are not updated to the latest recommended version. Let us see this in action. Now we can see, in addition to the service I just deployed, you also see another service deployed using the same service template. In a real-life scenario, there could be hundreds of such services deployed. Now let's say you have a new security requirement to scan all the Docker images before pushing to ECR as part of your build process. Normally, this could be a challenging task. However, to make this change across my services via Proton, first I'm going to update the service pipeline CloudFormation within the service template. to add an image scanning step during the build stage. Then I upload the bundled template into my S3. Now let's update the previously created service template with a new minor version. Select the S3 and select the environment that's compatible. Once created, now let's publish the new version. Now our new version 1.1 becomes a recommended version. Now if I go back to the service, I can see there is a minor version update available for the 2 servers deployed with the service template. To update the new version of the pipeline template, simply select the service and click to update the recommended version. Fast forwarding to the completion, now the service pipeline is updated successfully to the recommended version. Proton makes it easy for platform and the development team to quickly update their services, and also it provides the platform team a quick view on the service that are not up to date. Now if you go back to our initial problem on operational complexity around maintaining hundreds or sometimes thousands of microservices with constantly changing infrastructure resources and CI/CD configurations, it is an impossible task for even the most capable platform team. AWS Proton solves this by giving platform teams ability to publish approved stacks that your developers can adopt and deploy applications. It delivers the right balance of control and flexibility so that your developers can continue to innovate. Also, lets you easily adopt new features or best practices across your deployed services by letting you to update out-of-date applications with a single click. So now with AWS Proton, you can provide consistent architecture across your organization. Finally, AWS Proton lets you adopt new technologies like containers and serverless without slowing down your developers. It gives them infrastructure provisioning, code deployment, and observability in a single interface, allowing developers to focus on their code. As of this recording, public preview is now available across 5 AWS regions. As part of the preview, you can create templates using AWS CloudFormation and CI/CD pipeline using AWS Code Pipeline. And you'll be able to update templates, update the services and environments using Proton. Finally, let's look at some of the roadmap items planned for the service for the future. As mentioned earlier, it is in our roadmap to add support for third-party tools such as Terraform for infrastructure as code, GitHub Actions for CI/CD, Datadog, and New Relic for observability. Also, a new feature to enable administrators to define AWS account per environment and have all their resources for their environments created in that AWS account via multi-account support. And also, future support to define who can see and create services and environment based on specific templates via template access control. We also made our AWS Proton roadmap public via GitHub to help you view and also request for new features. What next? If you're facing similar challenges in managing microservices, please get started with the public preview of AWS Proton. And also follow our GitHub public roadmap page for new features. And also, please check out our open source Proton sample templates on common container and serverless use cases. Finally, please provide us feedback on your experience. This will help us to improve the service. You joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification for containers and serverless. We offer online digital training that is available on demand. You can go deeper with the 3-day instructor-led courses running containers on Amazon Elastic Kubernetes Service. You can also explore labs, white papers, and other technical resources by downloading the AWS Ramp-Up Guides. For more information, visit aws.training/learning library and select the container or serverless domains. Thank you for joining the session. If you enjoyed this video, don't forget to give feedback.